Class 5 Project Day display. Our topic is space. Space development of astronomy. Today, let me and my friends introduce you to the wonders outside our world. Hello and welcome to the Class 5 Project Day display. Our topic is space. Space development of astronomy. Today, let me and my friends introduce you to the wonders outside our world.
Where is space and what is it?
Space, Arhan, is a boundless three-dimensional extent in which objects and events have relative position and direction. Now, where is space? Space is known as Kármán line, an imaginary boundary 100 kilometers, which is equal to 62 miles above the mean sea level.
Oh, thanks for the explanation, Ahan.
Arhan, can you tell me what is outer space?
Yes, of course. Space, Ahan, is also known as outer space. It is the near vacuum between celestial bodies. It is where everything, all the planets, stars, galaxies, and other objects are found. The concept of space is considered to be of fundamental importance to an understanding of the physical universe. And now, you may also have the question that what is space made of? Well, outer space is not completely empty. It is a hard vacuum containing a low density of particles, predominantly a plasma of hydrogen and helium, as well as electromagnetic radiation, magnetic fields, neutrinos, dust, and of course, cosmic rays.
Thank you for telling me about outer space.
Ahan, could you tell me some facts about space?
Sure, Arhan, why not? How far did humanity travel in space? Both Voyager 1 and 2 are space probes launched to explore the solar system in 1977 and have now been in space for almost 44 years. Voyager 1 is now 152.5 AU away from our Sun, which makes it the furthest human-made object from Earth. In 2012, it reached interstellar space.
Oh, Ahan, that was quite interesting. And I would also like to say one fact on outer space. May I?
Sure, Arhan, go ahead.
The temperature of outer space is close to absolute zero. The temperature in space depends on how empty it is, where atoms having vast distances between one another, the heat won't get transferred easily, and life comes to an almost standstill point. And the average temperature in areas of empty space is minus 270.15 degrees Celsius, as in Fahrenheit, minus 457.87 degrees Fahrenheit. This temperature is not far from absolute zero.
Wow, that was fascinating. You remind me of Nicholas Copernicus.
Who is Nicholas Copernicus?
Let a few of my friends introduce us to Nicholas Copernicus and some of his fellow astronomers.
I am Nicholas Copernicus. I was a Polish astronomer and known as the father of modern astronomy. I was the first modern European scientist to propose that the Earth and the other planets revolve around the Sun. I suggested that the Earth's rotation accounted for the rise and the setting of the Sun and the movement of the stars. I also suggested the cycle of the seasons was caused by Earth's revolutions around the Sun I laid out my model of the solar system and the path of the planets.
Thomas Kepler defended and modified the Copernican view of the solar system with a radical reformation that established him as one of the great lights of the scientific revolution of the 16th-17th centuries. Kepler deduced that the planets do not travel in a perfect circle around the Sun, as Copernicus had thought, but rather proposed elliptical orbits, with the Sun at one of the foci. This insight formed the first planetary law, which he published in 1609, with the second law, which stated that planets do not travel at the same rate throughout their orbits.
I, Galileo Galilei, 1564 to 1642, stood as the central figure of the scientific revolution of the 17th century. With my work in physics, astronomy, and scientific methodology, I was born in Pisa, Italy, made numerous scientific discoveries. I famously proved that all falling bodies fall at the same rate, regardless of mass. I experimented with and refined telescopes, though I did not invent them, as is often incorrectly thought. I am perhaps best known for discovering the 4 most massive moons of Jupiter. I supported the Copernican heliocentric model of the solar system, publishing my arguments in favor of it in Dialogue Concerning the Two Chief World Systems during 1632. Today my legacy lives on in the Galileo spacecraft which probed Jupiter.
Isaac Newton lived from 1642 to 1727. He often commands respect as the most influential figure of all science. His creation of the 3 universal laws of motion plus the invention of theory of gravity permanently altered the field of science. In a story that has long since gone into public consciousness, Newton supposedly found inspiration for his theory of gravitation upon seeing an apple fall from a tree. From this, he concluded that gravity's pull could extend outwards from Earth, even as far as the moon and further. Newton's achievements have been celebrated in many ways, with statues and poems. Notably, the unit for force was named after him, the Newton.
Christian Huygens made advances in mathematics, physics, and horology, developing improved telescopes in 1655. He proposed that a thin, flat ring circled Saturn. He made the first known drawing of the Orion Nebula. Huygens proposed a wave theory of light. The modern theory of light involves a wave-particle duality model. Recently, Huygens' legacy was commemorated in the probe named after him, which parachuted on Titan in 2005.
I am Giovanni Cassini. I was born in 1624 in Perinaldo, Republic of Genoa, now Italy. Me and colleague Jean Richard used the parallax method to determine the distance to Mars from Earth. I was the first one to observe Saturn's 4 moons, Iapetus, Rhea, Tethys, and Dione. My name lives in the Saturn orbiter, which has studied Saturn and its satellites since 2004.
I developed an interest in astronomy at an early age. I was drawn to astronomy after I witnessed a 6-tailed comet in 1744 and later an annual solar eclipse in 1748. As a young comet hunter, I began to discover and note nebulas, as these frequently were confused for comets. Thus began my famous catalogue for deep sky objects such as star clusters and galaxies. The first version in 1771 covered 45 objects, eventually expanded by me to 103 objects. Later, astronomers filled out the catalogue to a total of 110 objects, which were known as Messier objects. Today, my catalogue is still used widely.
Albert Einstein, born in 1879, was a preeminent scientist of the 20th century. His theories of relativity extended so far to the universe. In fact, they changed astronomy forever. Albert Einstein's most revolutionary innovation came in the form of his theory of relativity, which states that the laws of physics are the same everywhere in space, which tells us that the speed of light is constant. The more faster an object moves, the more mass it gains, which leads us to the famous equation of Albert Einstein, which is E equals to mc squared, where E means energy, m means mass, and c means the speed of light.
Also the director of planetary studies at Cornell University. He made many scientific discoveries, including explaining the high temperature of Venus and the seasonal changes on Mars. He was the host of the show called Cosmos, and his catchphrase was billions and billions. He penned a science fiction novel called Contact, which was later adapted into a motion picture starring Judy Foster.
Neil deGrasse Tyson was born on October 5, 1958 in New York. He is an American astronomer who popularized science through his books and various shows. When Tyson was 9 years old, his interest in astronomy was sparked by a trip to the Hayden Planetarium at the American Museum of Natural History in New York City. He wrote the books Merlin's Tour of the Universe and Just Visiting This Planet. Later, as the director of the Hayden Planetarium, Tyson oversaw the replacement of the facility, which opened in 2000. The new planetarium exhibit categorized the solar system into groups, aside from his many books. Tyson popularized science on television and radio.
Now, let us see and learn about some Indian astronomers.
Ritu Karidar is a senior scientist in Indian Space Research Organization with a key role in realizing the Mars Orbiter mission, the first mission to reach Mars at the first attempt. Her dream of joining the space agency came true in November 1907. She has worked for many operations in ISRO and also handled the responsible position of Operations Director. She with her team is responsible for executing the critical operations of leaving the Earth and capturing Mars.
APJ Abdul Kalam, full form Avul Pakir Jainuddin Abdul Kalam. Born October 15, 1931, Rameshwaram. Died July 27, 2015, Shillong. An Indian scientist and a politician who played a leading role in development of India's missile and nuclear weapons program. He was President of India from 2002 to 2007. In 1969, he moved to ISRO where he was Project Director of the mission SLV-3, the first satellite launch vehicle both designed and produced in India. Joining DRDO in 1982, he planned is Nambi Narayan. I am an aerospace engineer. I work at ISRO. I was awarded the Padma Bhushan, the third highest civilian award given by the government in 2019. I developed the Vikas engine which was used in the first PSLV launched by India.
Wow, that was really interesting. Speaking of astronomers, why don't we research some facts about the science they study?
Astronomy is a natural science that studies celestial objects and phenomena. It uses mathematics, physics, and chemistry in order to explain their origin and evolution. Objects of interest include planets, moons, stars, nebulae, galaxies, and comets. Relevant phenomena include supernova explosions, gamma ray bursts, quasars, blazars, pulsars, and comet microwave background radiation. More generally, astronomy studies everything that originates beyond Earth's atmosphere.
The ancient Greeks developed astronomy, which they treated as a branch of mathematics, to a highly sophisticated level. The first geometrical three-dimensional models to explain the apparent motion of the planets were developed in the 4th century BC by Eudoxus of Cnidus and Callippus of Cyzicus.
The G means Earth. So the geocentric theory, which maintained that the Earth was the center of the universe, dominated ancient and medieval science. It seemed evident to early astronomers that the rest of the universe moved about a stable, mentioned as Earth, because the sun, moon, planets and stars could be seen moving about Earth along cyclical paths day after day. It was a reasonable assumption, for nothing seemed to make it move. Even the fact that objects fell towards Earth supported geocentric theory. Finally, geocentrism was in the keeping with the theocentric, God-centered worldview dominated Middle Ages when science was a subfield of theology.
The heliocentric system. In the book called On the Revelations of Deadly Bodies that was published by Copernicus laid on his deathbed, Copernicus processed that the sun, not the earth, was the center of the solar system. Such a model is called the heliocentric system. The ordering of planets known to Copernicus in this new system is illustrated in the model, which we recognize as a modern ordering of those planets. In this new ordering, the earth is just another planet, the third outward from the sun, and the moon is orbit around the earth, not the sun. The stars are distant objects that do not revolve around the sun. Instead, the earth is assumed to rotate once in 24 hours, causing the stars to revolve around the earth in the opposite direction.
What is zodiac? Earth orbits our sun once each year. Viewed from Earth, our sun appears to trace a circular path. This path defines a plane called the plane of ecliptic. The zodiac is a group of constellations that fall along the plane of ecliptic. It is through these constellations that our sun appears to pass during the year.
A pattern of stars within a constellation are called asterisms. The word constellation comes from a Latin term meaning a set of stars. The largest constellation is Hydra, which takes 3.16% of the sky, and the smallest is Crux, which takes 0.17 of the sky.
Aries is a
constellation and part of the zodiac. It was described by the 2nd century astronomer Ptolemy. It was the 48th model of the constellations. It was the 88th model of the zodiac sign, with along 11 other constellations of the zodiac sign.
Taurus is in the shape of a bull. Taurus is a large and prominent constellation in the northern hemisphere's winter sky. It is one of the oldest constellations, dating back to at least the early Bronze Age, when it marked the location of the sun during the spring equinox.
Gemini. Gemini is located in the northern celestial hemisphere. Its name is Latin for twins, and it is associated with the twins Castor and Pollux in Greek mythology. Cancer. Cancer is one of the 12 constellations of the zodiac, and it is located in the northern celestial hemisphere. Its name is Latin for crab, and it is commonly represented as one.
Leo is located in the northern celestial hemisphere. Its name is Latin for Leo.
Virgo is the second largest constellation in the sky after Hydra, and the second largest zodiac Virgo. It can be easily found through its brightest star Spica.
Libra, located in the southern celestial hemisphere. Its name came from Latin and its meaning is weighing scale.
Scorpio is located in the southern celestial hemisphere. Its name is Latin for Scorpio. They mainly live in desert.
Its name is Latin for archer. Sagittarius is often represented as a central, pulling back a bow. Capricorn name is Latin for horn goat or goat horn, or having horns like a goat, and it is commonly represented in the form of a sea goat, a mythical creature that is half goat, half fish.
Aquarius name is Latin for water carrier or cup carrier, a representation of water. Aquarius is one of the oldest of the recognized constellations.
Pisces is visualized as a distant pair of fishes connected by one cord, each that join at an apex. Its name is the Latin plural for fish.
That was a really good explanation on astronomy and constellations. Now, let us learn some facts on space science.
Facts about space. Space is any human-made object orbiting Earth that no longer serves a useful purpose. Scientists estimate there are about 5 lakh pieces of space-time today, including fragments from rockets and satellites, and every items like planets dropped during construction of the International Space Station.
The International Space Station is the largest manned object ever sent into space. At 109 meters long, the International Space Station ISS sits roughly 400 kilometers above the Earth and is the third brightest object in the night sky.
I want to talk about light. Light is a form of energy called electromagnetic radiation. Space is almost completely silent. In space, no one can hear you scream, but no one can really hear anything anyway. There are some vibrations and sound waves that are imperceptible to humans, but overall space is a vacuum and it's pretty darn quiet.
The Mariner 10 was the first spacecraft that visited Mercury in 1974. The first artificial satellite in space was called a Sputnik. It was launched by the Soviet Union into an elliptical low orbit of the Earth on October 4, 1957.
Any free-moving liquid in outer space will form itself into a sphere. This is because of something called surface tension, which is an imbalance of intermolecular attractive forces. This can also occur in low Earth orbit. Facts about space.
In 2016, scientists detected a radio signal from a source 5 billion light years away. This means that
when the signal started its journey, Earth didn't even exist. The detected signals were located using the Very Large Array (VLA) of the National Radio Astronomy Observatory in New Mexico.
Well, why don't we find out? Some of my friends are coming over. They can tell us about the instruments that scientists use.
This is a model of Hubble Space Telescope. Bruce McCandless helped deploy the Hubble Space Telescope into orbit from the Space Shuttle Discovery in 1990. Hubble Space Telescope is about the size of a large school bus. It weighs 24,500 pounds. Hubble orbits the Earth at a cruising speed of 17,000 miles per hour and takes 15 minutes to rotate 90 degrees. Hubble has observed locations more than 13.4 billion light years away, meaning it has seen light that existed in the universe 13.4 billion years ago. Astronomers using Hubble data have published more than 13,000 journal articles, making it one of the most productive scientific instruments ever built.
But to deliver stunning images of stars, galaxies, and other astronomical objects that have inspired people around the world and changed our understanding of the universe. The telescope has tracked interstellar objects as they soar through our solar system, watched a comet collide with Jupiter, and discovered moons around Pluto. It has found dusty disks and stellar series throughout the Milky Way that may one day become fully fledged planetary systems and study the atmospheres of planets that orbit other stars.
What is a spectrometer used for in space? A spectrometer, astronomers, which splits the light collected by a telescope into its colors. This allows astronomers to see the details in the light from space. Astronomers know how to get a lot of special information about a space object by studying its light. Spectrometers use lenses, mirrors, and other hardware to disassemble light into its component wavelengths, similar to how raindrops spread the sun's light into a rainbow. Cassini's infrared spectrometer performs the same trick but at the infrared wavelengths of light. Here I've done a very simple spectrometer. It collects light from here and the CD disassembles the light into its colors. And you can see the rainbow from here.
Mapping terrain and terrain laser scanning. This is a tripod. The tripod holds the scanner head. This is a telescope. The telescope is connected to the LiDAR box. LiDAR means laser detection and ranging. LiDAR sends a laser light to the target surface. The surface reflects the light back to the LiDAR equipment. The scanner head senses the light and measures the distance traveled. This data combined with the position and orientation of the LiDAR equipment creates three-dimensional coordinates, longitude, latitude, and height. This combination of data is called point. LiDAR equipment makes so many points. A collection of points is called point cloud. This point cloud is a crucial data that companies use to make 3D models of the terrain.
Pistol grip tool. It was the first successful computer-controlled astronaut-powered tool used in space. It was the brainchild of Paul Richard, Hubble program engineer. It was first used in 1997. It is a programmable drill with high torque that returns at a low speed for increased control. Pistol grip tool remains as the primary tool still used by spacewalkers in the 21st century.
The first series of motor planes were used on the space shuttle to deploy and move position of astronauts, repair satellites,
launched on 13th November 1981. Now it is displayed in the Canadian Museum. The robot crane is a work platform for space workers. Now I would like to indicate a few parts of a robot crane. This is the camera through which the robot crane takes pictures, and this is the photo storage.
What is safety terrorist used for in space? A space tunnel is a long strand of fibers used to couple a spacecraft with another mass, which allows the exchange of momentum or energy. Tethers can be used to change orbits of satellites without consuming any propellant, or to transport payloads from a planet to low altitude orbit.
Perseverance, nicknamed Percy, is a car-sized Mars rover designed to explore the crater Jezero on Mars. Perseverance has a similar design to its predecessor rover Curiosity, from which it is moderately upgraded. It carries 7 primary payload instruments, 19 cameras and 2 microphones. The rover also carried the mini helicopter Ingenuity to Mars, an experimental aircraft and technology showcase that made the first powered flight on another planet on 19 April 2021.
This is the checkers, this is the tools, this is the telescope, this is the buttons, and this is the buttons.
Now, some scientists say that they have managed to figure out the speed of light. But what is that?
Hi everybody. Today we are going to see about a simple technique which can be used to measure distance. It is easy because your eyes are in 2 different positions. Now first, try to face a background with a lot of objects in it, like a bookcase or a landscape of trees. First, hold your thumb at arm's length and look through your right eye, and then look at it through your left eye. Repeat this several times and you'll notice that your thumb is moving to block different trees or books. Now do the same method but keeping your thumb closer to your nose. You can see that the thumb moves farther to block the objects. Astronomers use the satellites in 2 different positions instead of 2 eyes to calculate the distance of a star instead of a thumb.
Tell you about it. Speed of light. Speed of light, speed at which light waves propagate through different materials. In particular, the value for the speed of light in a vacuum is now defined as exactly 299,792,458 meters per second.
The speed of light is considered a fundamental constant of nature. Its significance is far broader than its role in describing a property of electromagnetic waves. It serves as the single limiting velocity in the universe, being an upper bound to the propagation speed of signals and to the speeds of all material particles.
To find out the speed of light, we are going to use a partially reflecting mirror, a light source, a toothed spinning wheel, and a reflecting mirror. When the light falls on the partially reflected mirror, it tries to pass it on to the reflecting mirror, and in the between there is a spinning wheel that is moved in a certain speed that can be measured. The wheel cuts and lets go the light again and again until the spark of a sprint of a light that touches this is measured. The speed of light is 186,000 miles per second. It was denoted as C. The experiment was carried out in a vacuum, so there is no medium to affect the speed of light.
These astronomers have been researching the worlds outside ours for decades. To honor them, let us put up a small skit, shall we?
Well said, Rakshana. One scientist in particular that we would like to talk about is Nambi Narayan.
Yes, Kavya. Nambi Narayan is a man of exceptional standards. Due to his efforts today, many people are inspired to join the Indian Space Research Organization.
Nambi Narayan was born in a middle-class Tamil Brahmin family on 12 December 1941 in Nagarcoil in Travancore. He completed his school from DVD Higher Secondary School.
He met Vikram Sarabhai, who was then chairman of ISRO at 1966. They met at Tumba Equatorial Rocket Launching Station at Tumba.
He earned a NASA fellowship and was accepted into Princeton University in 1969. His master's program, a chemical rocket propulsion under Professor Luigi Crocco, was completed in a record 10 months. He was also instrumental in development of the Vikas engine that was used for the first PSLV rocket that India launched.
ISRO scientists led by Narayan spent 5 years in France working on the French engine and liquid technology that was used to develop India's own version of Viking named Vikas in the early 1980s.
Eminent space scientists like APJ Abdul Kalam and stalwarts of ISRO like Vikram Sarabhai, we are not convinced by Narayan's idea.
Let's use liquid fuels. They have the capability to generate more energy and can burn slower than solid fuels.
Besides, liquid fuel technology is more complicated. All international spacefaring nations have shifted to liquid fuels only after using solid fuels in their initial years.
I know that liquid fuels aren't easy to use, but let us just try this one time. I know that liquid fuels aren't easy to use, but let us just try this one time.
They did not stop Nambi Narayan from working on his idea. Upon his return from Princeton University, he was able to clinch a profitable deal with the French company SCP.
This model of Viking engine called Vikas was used many years later in the successful launch of Mangalyaan. However, the PSLV rocket couldn't hold enough fuel to do a direct-to-Mars flight.
So scientists working on Mangalyaan devised a unique way to launch the satellite into the orbit. They used the Earth's gravity boost and burst of fuel when the closest point to the Earth to shoot out of its orbit and spiraled it in such a way that the spacecraft could slow down enough to enter Mars's orbit.
The scientists also made some unique adjustments for building and launching the satellite.
No, this much fuel is not enough for launching the rocket to Mars.
Yes, she is correct. We don't have enough fuel to go to Mars.
This material will be too heavy for the rocket to take off. I think we shall use this material as it is very light.
The camera which we are gonna use can get damaged easily.
Yes, I agree that this will work as its camera has a hard screen.
Yes, she is correct. We don't have enough fuel to go to Mars.
This material will be too heavy for the rocket to take off. I think we shall use this material as it is very light.
The camera which we are gonna use can get damaged easily.
Yes, I agree that this will work as its camera has a hard screen.
This detector is perfect, but we need one more.
But I think this will also be fine since it's almost as good as that.
Oh no, we have lost the connection.
It must be some problem. I'm sure we will be able to connect within some time.
Don't worry, it got connected back again.
5, 4, 3, 2, 1.
In conclusion, Nambi Narayan is arguably one of the best space scientists and engineers alive today. He has made India proud with his remarkable ideas and development.
Thank you, Tashanvi, for shedding light on Nambi Narayan and his life. Many young scientists are inspired by him to stay in India instead of going abroad.
We all want to be an Indian space scientist.